Now that we've simplified rational expressions and multiplied and divided them, we're going to start adding and subtracting them. Okay, so just keep in mind whenever we add or subtract fractions, we have to have that common denominator. So for example, if I wanted to add 1/3 and 1/2, I can't combine them right now because I have a 3 and a 2. So you have to find that common denominator, which in this case would be 6 because that's the smallest number that both 3 and 2 go into. Then to make 3 have a denominator of 6, we're going to multiply top and bottom by 2. Then to make the 1/2 have a denominator of 6, we're going to multiply top and bottom by 3. Keep in mind that whenever we do this multiplying top and bottom, we're multiplying by 1. So this number here is just 1. This number over here is just 1. So I'm not changing the values, I'm just rewriting them as an equivalent fraction that has a common denominator. So once we multiply top and bottom, we end up with 2 over 6, because we just do 2 times 1 and 2 times 3, plus 1 times 3 and 2 times 3. So we have 2/6 plus 3 over 6, which now that they have a common denominator, we add straight across and keep the denominator the same. Then we simplify, which in this case it is simplified, so my answer would just be 5 over 6. So the steps when adding, still just like we've been doing, factor everything, right? It makes it all easier to see once you know what all the factors are, and it's easy to find a common denominator. Then you find that common denominator and multiply wherever you need to make sure every fraction has that common denominator. Then you just combine your like terms by adding or subtracting straight across, then simplify. When you subtract, you still factor everything like we just talked about. Find your common denominator, multiply where needed, but the only difference is when you subtract, you're going to have to distribute that negative. Okay, remember when we subtract our polynomials, like if I said x minus 7 minus 2x plus 1. All right, this negative has to be distributed, so it becomes x minus 7 minus 2x minus 1. Then from there, you can combine your like terms. So the only difference with subtraction is that you have to distribute that negative. So for a couple examples, all right, for the first one, I've got 4m over 7 plus 5n over 7. Right now, my common denominator is 7, and they both have 7. So I don't have to change anything. I'm just going to add straight across. So we get 4m plus 5n all over 7. I can't combine those. I can't simplify anything, so I'm just going to leave my answer as is. For the second one over here, we've got 1 over g cubed minus 5 over g cubed. Again, they both have the same denominator of g cubed, so I'm just going to combine my like terms. So we have 1 minus 5, which is negative 4, over that common denominator g cubed. And for this example over here, they both have d plus 5 as a denominator, so they have a common denominator. So I'm just going to write it out. I have 8d minus, and then in parentheses, d minus 6. Make sure you take this whole thing in parentheses, because I'm not just subtracting the d, I'm subtracting d minus 6, that entire term. And then this is all over d plus 5. Then when I go to distribute, I end up with 8d minus d plus 6 all over d plus 5. And then 8d minus d are my like terms. That becomes 7d plus 6 over d plus 5. And I can't simplify anything. There's no GCF or anything, so I leave it as is. All right, for my next example, I have a over a squared minus b over a squared minus b squared. So I'm going to go ahead and factor. I have a quadratic down here, or I have a squared and b squared, so I'm going to try to factor it. So this is difference of squares, so it becomes a plus b, a minus b. And this one's pretty simple because this is also a plus b, a minus b. They have the common denominator already, so I don't have to do any multiplying. So for this one, I have a over a plus b, a minus b, minus b over a plus b, a minus b. So then it becomes a minus b, right? I can't combine those. I don't have to distribute anything, over a plus b, a minus b. And then the a minus b's cancel. So I'm left with 1 over a plus b. And for the last example on this slide, I have 5 over k squared plus 2k minus 15. plus k over k squared plus 2k minus 15. So again, they have the same denominator, but we are going to go ahead and factor it. So I want to multiply to negative 15, but add to 2k, or to 2. So that's going to be 5 and 3, and I want the 3 to be negative. So we get k minus 3, k plus 5. Alright, so then I have 5 over k minus 3, k plus 5, plus k over k minus 3, k plus 5. And then I can't combine those, so I'm just going to write them as 5 plus k over k minus 3, k plus 5. Alright, 5 plus k is the same thing as k plus 5, because with addition, the order does not matter. So that means that those cancel, and I'm left with 1 over k minus 3 as my final answer. Right, then we have a couple more challenging problems where we're going to have to find a common denominator. So the ones we just did already had that common denominator. Now we have to do a little work. Right, so for this one I have 7 over 3z plus 9, or 1 over 9z. Right, so they both have a z, so the z is good to go. But 3 and 9 are not the same. So the one number that both 3 and 9 go into is 9. So that means that my common denominator for this example is going to be 9z. So that's something that both of these numbers go into. So that means this 1 over 9z is good to go. 3z to become 9z has to multiply by 3. So I'm going to multiply top and bottom by 3. 7 times 3 is 21. 3z times 3 is going to give me my common denominator of 9z. And I'm going to add that with 1 over 9z. So then I'm going to add straight across. So 21 plus 1 is 22 over 9z. And I can't simplify 22 over 9, so I just leave it as is. All right, for the example over here, I have an e minus 2 and an e plus 2. These are factors. I can't take away the 2 or add or subtract anything. I can only multiply whenever I'm finding my common denominator. So for this one, just like with that first example we looked at, 2 and 3, they don't go into each other, so we multiply to get our common denominator of 6. So here, I have e minus 2 and e plus 2. They don't go into each other because they're two separate factors. So my common denominator is just going to be to multiply them. So my common denominator is e minus 2 times e plus 2. So the e minus 2 is missing the e plus 2. So I'm going to multiply top and bottom by e plus 2. And then the e plus 2 is missing the e minus 2. So I'm going to multiply top and bottom by e minus 2. And I'm just going to write it out so that we can visualize it, because I've got 2 times e plus 2 over e minus 2, e plus 2, minus 9 times e minus 2 over e plus 2, e minus 2. Okay, so I've got to distribute. So for this one, I'm distributing a 2. For this one, I'm distributing a negative 9 because of that minus sign. So 2 times e plus 2 is 2e plus 4. Negative 9 times e minus 2 is going to be a negative 9e plus 18. And now I'm just adding because I distributed that negative. So 2e and negative 9e gives me negative 7e. And then 4 and 18 gives me 22. I don't have a GCF or anything for the top, so I'm going to leave it just like it is over e minus 2 times e plus 2. And for this example over here, I have y and y minus 4. Again, you have to multiply. I can't just say my common denominator is y minus 4 because I can't just subtract 4. I have to multiply by something. So they don't go into each other because I have y minus 4. They're different, so my common denominator is just going to be to multiply. Y times y minus 4. So the one on the left over here is missing the y minus 4, top and bottom, and the one on the right is missing just the y. So again, write it out so that you don't skip any steps. So I have 2 times y minus 4 over y times y minus 4 minus 3 times y over y times y minus 4. 2 times y minus 4 is 2y minus 8. And then the 3y is already simplified, so we have minus 3y over y times y minus 4. Because it's just one term, I don't have to distribute anything. So I have 2y and negative 3y gives me negative y. So I have negative y minus 8 over y times y minus 4. All right, and a couple more examples. So for the first one, I got n plus 3, which is already simplified. There's no factoring. Then n squared plus 3n. So I can factor this one. There's a GCF. So this one's going to become n times n plus 3. And then over here, I have an n. All right, so if I take n plus 3, there's another n plus 3 here. And then I have an n, which is another n here. So my common denominator is going to be n times n plus 3. All right, so then the n plus 3 over here is just missing the n, and the n is missing the n plus 3. The one in the middle is already good with n times n plus 3. Almost always, when you factor, if there's only one that you have to factor, the other terms go into that factored term. So whatever that quadratic is going to end up being your common denominator, almost always for the problems that we do. All right, so then here, 3 times n is 3n. So we have 3n over n times n plus 3. Plus, the middle one stays the same, don't have to multiply by anything. Plus 4 times n plus 3. All right, 3n stays the same. 2 stays the same. And then 4 times n plus 3 is 4n plus 12. All right, now I've got all of my distribution over with, my common denominator, so I'm just going to combine my like terms. So I have a 3n and a 4n, gives me a 7n, and a 2 and a 12 gives me a 14, and that's all over n times n plus 3. Now there is a GCF, so let's try to get a GCF out and see if we can simplify any more. So my GCF up top is 7, so I have 7 times n plus 2 over n times n plus 3. So there's nothing to cancel out, so I can't simplify it anymore, and this is my final answer. And for the last one, I have a squared plus 2a minus 3 and a squared minus 5a plus 4. So if I factor it, I want to multiply to negative 3 and add to 2a. So I end up with a minus 1 times a plus 3. And over here, I want to multiply to 4, but add to negative 5. So that's going to be a minus 4, a minus 1. All right, so they both have an a minus 1 in common, so that's part of my common denominator. But then I'm going to have an a plus 3 in there and an a minus 4. All right, so if the first one's missing the a minus 4, so I'm going to multiply top and bottom by a minus 4, and the second one's missing the a plus 3. So top and bottom times a plus 3. Okay, now when I multiply, I have a binomial times a binomial, so I'm going to have to FOIL. All right, so for the top one, we're going to have a times a, which is a squared, a times negative 4, negative 4a, negative 2 times a, negative 2a, and then negative 2 times negative 4, positive 8. All right, and at the same time, I'm going to go ahead and multiply this one over here. So I have a times a squared, a times 3, 3a, 2 times a, 2a, and 2 times 3, 6. All right, combine my top one, we get a squared minus 6a plus 8, all over a minus 1 times a plus 3 times a minus 4, minus, and then this other one we've got a squared plus 5a plus 6, all over a minus 1 times a plus 3 times a minus 4. Okay, I've got to distribute that negative. So I have a squared minus a squared, so they cancel. Negative 6a minus 5a is negative 11a. And 8 minus 6 is 2. And this is all over a minus 1, a plus 3, a minus 4. And there's nothing to simplify up here or to factor out, so then I just leave my answer as is with this big denominator.